Okay, in this video, you are definitely getting your bang for the buck because I'm going to show you not one, but two whole ways to solve this problem. Okay, so one way is if we just call y, oops, sorry, there's a dx over here that's actually very important. If we just call y the square root of 1 minus x squared, that would mean that solving for x and y, we could get y squared plus x squared equals 1. As you may notice, this is the equation for a circle with radius 1. So this right here is 1 minus 1, and it's at the center because there's no k and h. So we would just evaluate it from 0 to 1, which is, or from 1 to 0, which is right over here. So the area from 1 to 0 is this right here, which is just, as we know, we would use pi r squared over 4, where r is 1, so the answer is pi over 4, which is a really clever way of coming about it. Now, there's another way of doing it, which I'm going to write two trig identities for. I'm not going to go into too much depth in solving this one like I have previously. It's sort of almost left for a challenge for you to solve. And we'll have sine squared of u equals 1 minus cosine of 2u over 2. Okay, so another way that we could do this is we could, using our sine squared of theta plus cosine squared of theta equals 1, we say cosine squared of theta equals 1 minus sine squared of theta. So now we have cosine of theta equals 1, the square root of 1 minus sine squared of theta. And that looks a whole lot like this. So I'm going to say x equals sine of theta. Now I will have the integral from 1 to 0 of 1 minus sine squared of theta. And now dx, I need to solve for that. If x equals sine of theta, that means that dx equals the derivative of this, which is cosine of theta d theta. And that's about it. So now, plugging in for d theta, we'll multiply this by cosine of theta d theta. So this equals, from the integral from 1 to 0, that looked pretty ugly. The integral from 1 to 0 of cosine of theta times cosine of theta. So it's cosine squared of theta times d theta. I know over here, this is where these two identities come in handy. I'm not going to go through all of it, but we are going to, this is like an exercise for you to do. The end result is going to be theta over 2 plus sine squared of theta over 2, evaluated from pi over 2 to 0. Now, how did we get from pi over 2 to 0 from 1 to 0? That I will go over. So we have when x equals 1, theta will equal, if we go back into here, theta will equal pi over 2 because the sine of pi over 2 is 1. And then when we have x equals 0, we will have theta also be 0. Theta equals 0. So now we've, doing the substitution, we've changed the values of the integral, like the area of where it's going at. So now it's at pi over 2 to 0. So now I'm just going to plug in for this. So it'll be pi over 2 times 1/2, which is pi over 4, plus sine squared of pi over 2. Sine of pi over 2 is 0, so its squared is also 0. Divided by 2 is still 0. Minus 0 over 2, which is 0, plus sine of square root of 0 over 2, which is still 0. So this whole thing turns out to be pi over 4, which is just what we got up there. So now you've seen two different ways of solving it. The way where you substitute the sine of theta is really the way that you're going to want to do it later on. But this is like a nice little cute way of looking at it. So thank you much for watching, and goodbye.